Okay, good day, class. How are you guys doing? I hope you guys are good. So, good morning, good afternoon, good evening, wherever you are, or whichever time you are watching this video. This video is brought to you by our Saviors College, Ore, Ondo State, the first and the best. So, very quickly, let's dive into what we have to do today. So, today, the topic we are treating in physics is equilibrium of forces. Before I go into this topic, I need you to know that whichever topic that is being brought to you by the physics department in our Saviors College, just know that it is to the UTME standard. It is to the external examination standard for secondary school students. So for those of you that are preparing for UTME, this is the best fit for you. For those of you that are currently in your secondary school, your senior classes, this is also the best fit for you. Without wasting much of our time, let's dive into the topic. Equilibrium of forces. When we hear the word equilibrium, there is a word that you can use to replace it, and what it means is simply balance. Equilibrium simply means balancing forces. And so, very quickly, there are some concepts we need to learn that will usher us into understanding the full meaning of what equilibrium of forces is. So, the first concept we will be learning today is knowing about moments. And the first one is moment of a force. So when we talk about moment of a force, you can see the definition says moment of a force about a point is the product of the force and the perpendicular distance of its line of action from the point. They said moment of a force is equal to the force. Moment of a force is the product of the force and perpendicular distance. And now when we talk about moment, moment simply means the turning effect of a force. The turning effect. So the best example for you to understand what a moment is just like your tap water that you use at home. When you are about turning it, the force that is making it to turn about its point, about a point, can you see it, is what we call moment. And so moment of a force is the product of that force multiplied by the perpendicular distance moved. So very quickly, we will now check the principle of moments. You see, in physics, in science generally, science is governed by different principles. And so I do tell most of my students, anything that makes you to understand the principle, if you can understand the context of what the topic is saying, you're already 50% done in that topic. Are we together now? So, principle of moments. Let's state it gently as science students now. They said, principle of moment states that when a body is in equilibrium, listen to the first thing. When a body is in equilibrium, the sum of anti-clockwise movement, look at it now, anti-clockwise movement at any point must be equal to the sum of the clockwise movement. What do we call anti-clockwise? Anti-clockwise is when a clock is moving like this and clockwise is like this. So for a material to be in equilibrium, for forces to keep a body in equilibrium, that means there must be an equation between anti-clockwise moment and clockwise moment. So now, a very brief example is when I take this note and I try to balance it on my finger like this. I hope you can see it. So if I try to balance this note now, this note is in equilibrium. And why is it in equilibrium? You can see that, okay, let me use this foam pouch if it's going to balance. Hey. Now, can you see now? This is in equilibrium. And what is actually keeping this to be in equilibrium is that the sum of the anti-clockwise that should make this pouch to turn like this is equal to the sum of the clockwise. And so if these both forces, or the sum of the anti-clockwise moment and the sum of the clockwise moment, if they are equal, definitely this pouch will be in equilibrium. And so as you can see now, it is in equilibrium. But the moment anti-clockwise moment, if they go greater than clockwise, it will tilt the phone pouch like this. Are we following it now? And if the clockwise movement should be greater than anti-clockwise movement, it will go out of equilibrium by pushing it sideways. Are we together now? So that is what we mean by anti-clockwise movement and clockwise movement. So when they are equal, it keeps any object that is between it, it keeps it in equilibrium. But it does not stop. It does not stop there. It doesn't stop at anti-clockwise and clockwise. Look at the next thing they talk about now. In addition, they said the sum of forces in one direction is equal to the sum of forces in opposite direction. Look at this now. This is a direction, right? And now this is another direction. So they are saying the sum of all the forces that are acting from the left, if they should be equal to the sum of forces that are acting from the right, definitely any object that is in between will be in equilibrium. Yes, that's what it means. One direction, the sum of forces must be equal to the sum of forces that are coming in opposite direction. And that also applies to upward and downward forces. That also applies to upward and downward forces. So when you have forces that are acting downwards, so for a bar to be in equilibrium, definitely downward forces must also act. So for this thing to be in equilibrium, for this uniform meter rule or bar, uniform bar to be in equilibrium, that means upward forces, they are acting in one direction, must be equal to the sum of the forces that are acting in the opposite direction. That is the principle of moment. Remember, anti-clockwise must be equal to clockwise, and also sum of forces in one direction must be equal to the sum of forces that are coming in opposite direction, either sideways or vertically. Now let's move to the next slide. So now we are delving straight into solving UTME questions under this topic. So we want to start tackling questions under equilibrium of forces, UTME questions. Now the first question we have here, they said, look at it now, this question is very, very simple. And so one of the things that will make you to be very good at this topic is if you learn how to analyze based on the principle of moment. Now look at this, they said a body of mass 58 grams is suspended at the 20 centimeter mark. Now let's go. The first point I will be giving you, let me just read the question. They said a body of mass 58 grams is suspended at the 20 centimeter mark of a uniform meter rule. Now, they now said the meter is adjusted on a pivot until it settles horizontally at the point 40 centimeter mark. Determine the mass of the meter rule. Let's look at this now. First thing, a body of mass 58 grams. We have mass to be 58 grams. Suspended at the 20 centimeter mark of a uniform meter rule. Now, note this. The length of a uniform meter rule is always equal to 100 centimeter. I need you to note this and write it down. Because UTME will not come and tell you that it's equal to 100 centimeters. So you must put it in mind that uniform meter rule. The uniform meter rule, its total length is 100 centimeter. Except if a part of it is broken. That's when it may not be up to 100 centimeters. But the standard length for uniform meter rule is 100 centimeters. So now, let's go. So first thing in solving equilibrium of forces, to solve questions like this, the first thing is you need to draw your uniform meter rule, because that is the object we are trying to keep in equilibrium. So take for example, this is our uniform meter rule. Then now they said a body of mass 58 grams is suspended at the 20 centimeter mark. This place is 0 centimeter, this place is 100 centimeter. You remember I told you that the total length of a uniform meter rule is 100 centimeter. So that means from here is 0, this place is 100. Now, at the 20 centimeter mark, please, I need you to know that for this now, you don't need to be using your ruler or whatever. You can just use your normal logic just to point where it is. So now we all know that the middle will be 50 centimeter, right? So the middle, at the midpoint, it will be 50 centimeter. So they now said body of mass 58 grams is suspended at 20 centimeter mark. So I'll put my 20 centimeter mark here. This is where a body of mass 58 grams is suspended. This is a weight. This is a mass rather, suspended. Then the next thing now, they now said the meter rule is adjusted on a pivot. What is a pivot? Now, you remember the other time that I used my hand as an example to explain equilibrium of forces for anti-clockwise and clockwise movement. Now, what my hand is doing right here is the work of a pivot. And so for some of us that are Nigerians, I believe that every Nigerian, we should know some of the games that we play when we were younger. And that's the, what do we call it? Jangilova, right? You know, for you to play Jangilova, is always like this. There will be a log of wood, then there will be a stone here, your elder brother will be here, then you will be here, and then you guys will enjoy the game. So the stone that is making that Jangilova to be possible is what we call the pivot. Are we together now? That's the pivot. That's where equilibrium happens. That's what brings about equilibrium. So they now said the meter rule is adjusted on a pivot until it settles horizontally at what? At the 0.40 centimeter mark. So now that means where they put the meter rule is very close to the midpoint, which is 40 centimeter mark. So most times we represent the pivot like this. This is the 40 centimeter mark. So now, if you bear with me, they said the 58 grams mass is suspended at the 20 centimeter rule. So I think we can go like this. The length from this place to this place is 20 centimeter. True or false? Yes, we are together. Now, the length from this place to this place is what? Is 40 centimeter. I hope you remember. 40 centimeters. Now, what is the question? They said, determine the mass of the meter rule. Determine the mass of the meter rule. Now, for you to be able to accurately measure the mass of any object or body, you measure the mass at the center of gravity of that object. I don't know if you got what I just said. To get the mass, sometimes now the weight of an object or of a body, it is determined at the center of gravity. So now, as I am now, to calculate my mass or my weight, it must be at the center of my gravity now. Are we getting it now? So it is not possible now that maybe you want to calculate the weight or the mass of this object, you must always calculate it downwards. That means gravity must act on it. Gravity must act on it for you to be able to determine the mass or the weight. It's not possible for you to want to determine mass and then you try and be putting it like this. It's not possible. It has to be downwards. So gravity is determined at, mass or weight is determined at the center of gravity. And so the center of gravity of a uniform meter rule is at the midpoint. Are we together now? That's where you find the mass. So that means what we are looking for here is the mass of the meter rule. Are we together now? We don't know that. That is M. And that's what we are looking for. And now, if you will recall to our moment of a force, they told us that moment of a force is simply force multiplied by what? Perpendicular distance. Don't forget. They said moment is force times perpendicular distance. Now, in this case now, if what you have is mass, you can see that what we have is two masses. And then one of them is unknown. We have known one of them. So the way to calculate this now, first thing, remember from the principle of moment that there is anti-clockwise and there are clockwise moments, right? So now, what this pivot does is that it makes us to know the forces that are acting in the clockwise moment and the anti-clockwise moment. So if you look at it now, from here, this mass now is trying to drag this equilibrium. It's trying to drag this metal rule rather. It's trying to drag it down like this. That means this is anti-clockwise. Are you together? Are we together now? So this guy is trying to turn this straight metal rule. He's trying to turn it like this. That's anti-clockwise. And so this other guy is trying to turn it like this. That is clockwise. So you remember, if both of them can be equal, this guy will be at equilibrium. Are you following it now? But if they are not equal, it will not be at equilibrium. So what we are going to do now, to calculate moment of a force now, first thing, write out the principle of moment. Anti-clockwise moment equal to clockwise moment. Are you following it? Please, I'm not putting the y's and the y's. I know you already understand that. Anti-clockwise equal to clockwise moment. And now, what are the anti-clockwise moments here? I already told you that this is the anti-clockwise moment. The guy after the pivot, right? The guy before the pivot to this side is the clockwise. These guys. So the pivot is the one that is dividing it into clockwise and anti-clockwise. So this is anti-clockwise, this is clockwise. So everything here, they are clockwise. Everything here, they are anti-clockwise. Are we together now? So now, the anti-clockwise moment, now, what do we have? We have mass. So that will be mass multiplied by the distance of this mass to the pivot. That's what you need. The distance, either be it force or mass, the distance of this mass to the pivot. And so what's the distance of this mass to the pivot? Let's look at it. They told us that 58 grams suspended at 20 centimeters. 58 grams suspended at 20 centimeters. Then the pivot itself is at 40 centimeters. So if you bear with me, what will be the distance between this place now? 20 centimeters. Right? If everything here is 40, this guy has taken 20. This guy is left with 20 centimeters. So definitely that means we already have 20 centimeters. Let's just go directly now. So what's the mass now? 58. So we have 58 multiplied by the distance of this mass to the pivot is what? 20 centimeters. Are we together now? If you notice, there is something we are doing here that is not acceptable in the physics class, and we are using a unit that is not the SI unit directly. Are you following it now? I'm just trying to explain so that you will understand where we are going. But if you are doing it for the standard SI unit, I hope you all know sometimes it depends on whatever the option is left in. Sometimes they leave the option in grams. Are we together now? So if the option is left in gram, no need to convert this to kilogram. But if the option is in kilogram, you need to convert. I think that is clear to everybody now. Okay now, so the next thing we are going to do, we'll say equal to, now, the 20 centimeter, we need to convert it to meter, true or false? We need to convert it. To convert 20 centimeter, I told you that centi stands for 100. So to convert 20 centimeter to 100, we say 20 divided by 100, and that gives us 0.2 meters, right? So that means our distance is 0.2 meters. Then for the clockwise moment, it will be mass that we don't know, the unknown, multiplied by what's the distance of this guy to pivot. Now, I hope you still remember that the distance from this place to the midpoint, this is the midpoint, right? The distance from the other end to the midpoint is 50 centimeters, right? So if it is 50 centimeters, pivot has already taken 40 centimeters out of it. How many centimeters are left here? Just 10 centimeters. So now we convert 10 centimeters to meters, and then we have 0.1 meter. Are we getting it now? So then we say 0.1 meters. So now what do we do now? 58 multiplied by 0.2, we have, very quickly we can just say 2 over 10 multiplied by 58. So we say 2 here, we say 10 here, 1, 10 in this one, 5.8. 5.8 times 2, we have 10. That's 11.6. Are we together now? So we have 11.6 here. 58. I'm going to be here. Yeah. 11.6 equal to 0.1 m. So what do we do here? We divide both sides by 0.1 divided by 0.1. 0.1 cancel 0.1, and then our m equals 11.6 divided by 0.1. Okay, 11.6 divided by 0.1. Okay, so let's try and do it like that. So we have 11.6 divided by 1/10. That's multiplied by 10/1. 11.6. So 11.6 multiplied by 10 will give us 116 grams, and that is the answer. Is that clear? I believe with that you already have a glimpse of what equilibrium of forces are, and then how to solve and analyze questions under equilibrium of forces. So in our next class, we'll be solving some more technical questions under equilibrium of forces. Till then, I'll see you later. Thank you.